The original nuclear magnetic resonance experiment, imagine a bottle of water, right? And the water is H2O, so it has 2 protons, 1 oxygen. You put it in a high magnetic field, that does nothing. You have your protons that are aligned parallel and anti-parallel to the magnetic field, and the magnetic field is the table, right? Because we put it in the MRI machine. In the MRI machine, the coils are going this way. The table is the long axis. That's the Z dimension, and that's where that's where the fringe fields are around the MRI machine, and the table is essentially the long axis. So that's your B0. B0 is the nomenclature of the static magnetic field. You put that bottle of water in there. All that's happened is essentially that you have spins that are resonating parallel and anti-parallel to the static field. The original experiment, I'm not going to get into, was varying the magnetic field, and therefore when it would hit absorption, when you'd hit you'd vary the static magnetic field, and when you'd actually hit the Larmor frequency, you would actually get an absorption, and then you go back down. The other way, the way we do it conventionally, is that when a patient goes into an MRI, they will put a coil, a radiofrequency coil around the body about the anatomic part that they're interested in imaging. Let's say it's your brain. And then by putting those coils around the anatomic body or part that's being imaged, those coils are actually tuned to transmit and receive radio frequency information exactly at the Larmor frequency, right? So they're tuned to that frequency. The reason why that's important is if you transmit energy at any frequency that's not quite at the Larmor frequency, that is going to be energy that's not at the spin difference, right? That energy well, and therefore it won't be absorbed by the bath of protons. You can imagine your brain is a bath of protons or a bottle of water. So then as soon as that energy is transmitted, what you call nutate, imagine that we're in that rotating frame again, so I'm sitting on all of those protons, and then I'm spinning at the Larmor frequency, so then I'm a static vector in the Z dimension. Then I put on a pulse of radio frequency energy at the Larmor frequency, and I nutate that vector down into a plane that is orthogonal to the static magnetic field. So it goes into an XY plane because the Z plane, the Z direction, is the static magnetic field direction. If I put a pulse for a small amount of time, hundreds of milliseconds, energy at that frequency, you'll absorb energy. That vector wants to turn, right? So if I put it on for a long period of time, I will allow that vector, which was originally going in the direction of the table, to want to move in the plane, spinning around the plane of the axis that I put the energy on, right? So because I'm imposing energy, and it wants to nutate around and spin around the axis that I want. So if I put it in the X direction, it wants to go in the ZY direction, right? Because it wants to spin around that direction because I'm putting energy in. If I put it in for a short amount of time, it will go into a plane that's perpendicular to the static magnetic field. And then if I put it on and then listen, it will then emit radio frequency energy at the Larmor frequency back to the system so I can listen to that, and that is essentially a dampened sinusoid. And the frequency of that sinusoid is at the Larmor frequency, and it's dampened because it relaxes back to its normal state, which is parallel and anti-parallel to the system. Anytime I put energy in, it has to relax back to its normal state. That's the NMR that's the NMR effect, essentially, because if I took the Fourier transform of that damped sinusoid, I'd get back one peak and that peak would be at the Larmor frequency, and I get one peak only because it's water. If I did ethanol, for instance, which is CH3CH2OH, there are 3 different classes of protons, I would get 3 peaks for ethanol. I choose ethanol because it's a university, and I would imagine that the university students are familiar with ethanol. That all being said, you haven't gotten an image yet, right? So now you need to impose spatially varying magnetic field gradients, right? X, Y, and Z. And then those X, Y, and Z gradients allow you to convert frequency information into spatial frequency information. And that's where the MRI comes into effect. You can actually then devise these pulse sequences which allow you to select a certain slice of spins, right? Only excite those spins. Excite means that I only transmit the energy to these spins in this frequency bandwidth, and then I can encode the information spatially in the other dimensions by properties of the Fourier transform, which allows you to convert frequency information into time or space in this case.